Now, what is a transistor? If you are aware, a diode, you can, if anybody will ask you what is a diode, the simple answer is diode is a two-terminal, two-layer, one-junction semiconductor device. Fine. It conducts in one direction, or it is on in one direction, and in opposite direction it is off. This you all are aware of. Now, as far as transistor is concerned, transistor is a three terminal. Listen to me carefully. Can you see this screen? This is how a practical transistor looks. Whether this one or this one or this one. If you have done some projects in your studies, then you must have used transistors. Maybe you are not familiar with the name, but it is a very important device. So what I was telling is, a transistor is, this is for example a transistor, or this is a transistor. So what is a transistor? It is a three terminal. What is the terminal? One terminal is this one terminal is this one, and one terminal is this one. So how many terminals? Three terminals. Then three layers. What are the layers? This is the first layer, this small second one, and this is the last layer. How many layers are there? Three layers. You can see PNP or see figure below. This is NPN, again three layers. So transistor is three terminal, three layer, two junctions. You know what is a junction? The place where two layers meet. So what are the two junctions? One junction is this one, and another junction is this one. So just to summarize again, transistor is a three terminal, three layer, two junction semiconductor device. It is of two types. How many types? Two. Let me change the color. One is called PNP and another one is called NPN. Fine. The figure above is about PNP. You can clearly understand from the figure. And the figure on the right bottom of your screen is NPN transistor. Now these transistors name PC have specific meaning, and here it is. E stands for emitter, B stands for base, and C stands for collector. Now, how it is designed, if you understood a p-n junction diode, you can understand it in an easy way. We take a pure semiconductor. It will be silicon or germanium, but most of the time we prefer silicon because of its advantages over the germanium. Now we do doping. You know what is doping? Doping is the process of mixing impurities to a pure semiconductor material to increase the conductivity. Now if you're designing a p-type PNP semi transistor, then this place we will add trivalent impurities, this place we will add pentavalent, and the remaining right again trivalent. Natija, you will get PNP transistors. Fine. Now NPN is opposite of that. What is the way? In very brief, we take a pure semiconductor, most of the time silicon, and we doping. On the leftmost side, we add pentavalent, middle trivalent, and right remaining again pentavalent. This is how we design an NPN transistor. Fine. So this is what is mentioned here. The main, the basic function of a transistor is what? To amplify. It is current. To amplify the signal. You know what is amplification? Amplification means increasing the strength of the signals. For example, your radio, the signal that you get and receive in the antenna is very, very weak in microvolts. But the sound you hear in the output, the news you hear in the form of sound is in terms of volts. So you have to increase the level of your signal. And how we do this? By the use of amplifier. You know amplifier, for example, you have seen loudspeakers. If you are speaking in a crowd of 10,000 people, your voice may not reach to everybody. So what do? You take speakers. You talk very slowly, but speaker increases the volume of your sound. This is a simple example of amplifier. So this is the main use, and all electronic circuits needs amplifiers. Now the next thing will be the working of a BJT. Before we will go to working, you have to understand how we know it is P or N. In case of diode, you know diode diode symbol looks like this. And from this is symbol for arrow, right? From arrow you understand that this is P and this is N. So how you know from symbol bus it is P or N? See this arrow. Can you see this arrow? It is going from E to B, and arrows go from standard P to N. So it means it is P and it is N. If it is P N, of course the last will be again P. If you have understood, listen again. See this figure below, this one. Here is the arrow. Arrow is going down, and arrow goes from P to N. If it is Pn, means of course the top will be N. So this is the symbol. By arrow itself, you can understand your transistor is NPN or PNP. If you have still doubt, see this part, listen this part again, and you will be clear. Now coming back to the working, we apply our input signal on the left side of the circuit or the transistor, and we collect our output on the right side. Can anyone tell me by seeing this figure whether it is PNP or NPN? Who will tell me this transistor, is it PNP or NPN? What is the way? See this arrow. This arrow is going from this place to this place, and standard is arrow goes from P to N. If it is PN, then of course last will be again P. So it is a PNP transistor. Hope it is clear. Now, in this case, in E, current is called IE or emitter current. In point B, the current moving from this point is called base current, and here at point C, the current entering will be called as collector current. Now, this configuration is called as common base. Why common base? See, this is your base. I said you will apply your input here, and you will apply your output here. In both input and output, your base is there. Why? Your input is between emitter and base. Your output is between collector and base. So base is there in input and output both. Thus, this is called as common base configuration. Fine. Now, if you will visualize in another way, see this. I will represent this in a simple way. It looks like this. This current is IE. This current is IB, and this current is IC. So in this case, this is a case. This is a point. So you can put KCL or Kirchhoff's current law, and you will find IE equals to IB plus IC. It means emitter current is equals to the summation of base current and collector current. And practically, the size of this base is so small or so narrow that this current is almost zero. So if you neglect, almost IE is equals to IC. This is a very important formula, these two. Make sure you remember this. What is the formula? IE equals to IB plus IC. And since IB is very small, almost IE equals to IC. Now, the earlier figure or circuit or configuration we are talking about is called as common base. Why? Because base is there in both input and output. So this is not the only configuration we use. This is what we have studied so far, but some other configuration you will use in practical circuits are common emitter and common collector. So we will discuss one by one all of them. You know what is configuration? Configuration means circuit arrangement, how you design your circuit. So there are three ways in which you can design circuit. Let us discuss one by one. Common base. Common base is what we are studying just now. Your base will be in common in between input and output. Your input is here and your output is here. Since a base is present in both input and output, it is called as common base configuration. If you will visualize the characteristic, you will see that there are two types of characteristic you can get. One is called as input characteristic and one is called as output characteristic. Now, what is a characteristic? Characteristic means calculating or observing or finding current at different voltages. So since there are two junctions, one here on the left side, another here on the right side, there will be two characteristics. Since we apply our input signal on the left side, the characteristic near this junction is called as input characteristic. Whereas junction on the right side, where we see our output, another name is output characteristic. So input characteristic between input voltage and input current, and output voltage is between output voltage and output current. Your input current is emitter current, so you will see here an input voltage between emitter base, so voltage emitter base. It is similar to diodes. For different output batteries, different characteristic you will get, but it is very much similar to a diode. Now, if you see output characteristic, output is collector, so collector current, output voltage collector base, so collector to base voltage. And this is what you are going to, we are not able to perform practically, so I cannot prove you that you are going to get this one. But if you have a lab and if you will verify, you will see the very same characteristic of the transistors you are observing. So this is the output characteristic of your transistor. Now in this case, there are three regions, places. There are three important regions. One is this, one is this, one is this one. This is called as this. Can you see this lower person? This is called as off. Why cutoff? Because there are two junctions and both of them will be reverse bias. Then this is called as cutoff region. Now this one on the left side of your output characteristic, this is called as saturation. Both junctions are forward bias, and this is the most important region, and this is called as active region. In this junction, your input is forward bias and output is reverse bias. Similarly, common emitter, a small change. You see, before this base was here, so we said common base, but now circuit is not like that. Now your emitter is there. This emitter is there in input and also in the output. Since emitter is common to both input and output, it will be called as common emitter configuration. Again, we will draw the characteristics, and there will be two characteristics. One will be for input junction and you will call input characteristic. Another for output junction, you will call it as output characteristic. Input characteristic between input current. What is input current? Go back side. This is input and this is base. So result is this current is input current. Okay, you see again here this base current. One important difference I want you to notice here is, see this current and this current. This current is in microampere, this current is in milliampere. We have discussed earlier that base is very narrow and current in base also is very, very small. This is the reason why it is milli and micro practical. Again, if you'll see, this characteristic of input is similar to a diode, and output characteristics have again three regions: 1, 2, and 3. This is called cutoff. Both junctions are reverse bias, saturation, forward bias both junctions, and this is the important place: active region, input forward and output reverse. Now common collector, again if you understand last two topics, collector is there between input and output. It is, we are not going to discuss much about this, but anyway, this is how a practical circuit look. Collector is there, input between base collector, output between emitter and collector. So as discussed earlier, the output characteristic has three parts: active, cutoff, and saturation. Cutoff, both junctions are reverse bias; saturation, both forward bias; and active is important, where input is forward bias and output will be reverse biased. Fine. And we have discussed this law: I equals to IC plus IB, but IB is very small, so IC is almost equals to IE. And VBE. Now what is VBE? Now if you go to, for example, this is base, this is emitter. So voltage here is called as VBE, and it is similar to diode. And since we use silicon for transistor also, this value is the cut-in voltage for silicon. Can anyone tell me what is the cut-in voltage for silicon? It will be 0.7 volt. Now these are the important equations. So now what I want is to